Hello, I'm Trena Wilkerson, President of the National Council of Teachers of Mathematics, and I'm also a professor at Baylor University in Waco, Texas, in the United States. So welcome to Envisioning Research in Mathematics Education, a global approach. Today, what I would like for us to do is to examine the recommendations from NCTM's Pre-K through 12 Catalyzing Change series and begin critical conversations about implications for mathematics education and research. Also, to better understand the factors that affect mathematics learning and ways to influence policies and practices to impact pre-K through 12 learning of mathematics through research. And third, to explore ideas for research and consider ways to form and foster partnerships to engage in that research across grade levels. So let's first take a look at Catalyzing Change. In 2018, NCTM released Catalyzing Change for high school, and it was to initiate critical conversations at the high school level to think about mathematics teaching and learning. One of the things we soon realized, though, if you're going to think about changes for high school, then we also need to think about early childhood and elementary, as well as middle school. And so in 2020, those two versions were released. If you go to nctm.org/change, you'll see some additional information about these books that were written and the recommendations that were made. There are case studies to see how some people are doing this. There are different resource guides, book study guides, and a lot of helpful resources there that I hope you might engage in should you be interested. There are also webinars that unpack these in greater detail than what we're going to do today. But what I want us to do today is use these as a way of thinking about research. So across the three documents, there are four recommendations. First recommendation is broaden the purposes of learning mathematics. The second is to create equitable structures in mathematics. The third recommendation centers on implementing equitable mathematics instruction. And the fourth is developing a deep mathematical understanding. So let's take some time to think about these a little further. One of the things you will notice is that the four recommendations span all three grade bands. Now, this particular document is too small to read on this screen. However, you can go to nctm.org/change and go to the webinar series and you will find this handout. I've also posted the link on this slide should you want to use it as well. And what I want you to notice is that while there are four recommendations in their three grade bands, they are similar across, just a little bit of wording change depending on the grade level that is being targeted. So let's unpack these a little bit more and think about the research aspect of it. So first is broadening the purposes of learning mathematics. Why do we study mathematics? And you will see that there are three main areas that stand out. One is to help students become very confident, capable learners, so they believe in themselves. The second is understand and critique our world, which is extremely important today. And third is my favorite, is to experience the wonder, joy, and beauty of mathematics. And you will see that these three main messages go across all the grade levels. So what does research have to say? What other types of research would be beneficial in understanding ways of broadening the purposes and the impact on learners, teachers, families, and others? And just who are our partners, our stakeholders in this? So let's consider aspects of this recommendation. So the second recommendation is creating equitable structures in mathematics. So let's consider this recommendation as well. And again, it's the same recommendation across all three grade bands, but the wording is different. So for example, in the equitable structures in early childhood, elementary, and even into middle school, we have to look at dismantling inequitable structures such as ability grouping and tracking so that every student has access to quality, exemplary mathematics instruction and high quality mathematics. And you can see this goes on into high school, the idea of detracking so that all students have access to quality mathematics. So what are the support structures that are needed to dismantle and disrupt these policies, practices, or procedures that might be limiting access to high quality mathematics teaching and curriculum? So what kind of data is needed to understand the impact on students? So we need to think about what current research there is about these areas to see what it has to say. What else should we be looking at in the way of research to look at these equitable structures? And again, who are those partners that we need to be working with? The third recommendation is implementing equitable mathematics instruction. And you may be familiar with these because they're based on the 8 practices and principles to action, which I'll talk about in a few minutes. But again, you will notice across the 3 grade bands, it's important that at all grades that we have implementation of equitable mathematics instruction so that every child develops a positive mathematical identity, strengthens their sense of agency, and sees themselves as a thinker and doer of mathematics. And we need this for all of our students. So what partnerships should be fostered for educators' professional learning to strengthen understanding of mathematics and equitable mathematics teaching practices? So let's unpack these just a little bit more. And remember, think about the idea of who are our partners, what type of research is there already, and what additional research would help inform practice. So on this slide, you will actually see 2 frameworks for thinking about equitable mathematics instruction. On the one side in the blue diagram that has the chart, these are the 8 mathematical practices that were described in Principles to Action in 2014. It was followed up by a series called Taking Action that unpacked them even further by grade band to help us understand them better and what they would actually look like. But it starts out by establishing a mathematics goal for the learning, then implementing the tasks that would facilitate this learning and problem solving, then the idea of looking at procedural and conceptual understanding. And you'll notice the ones, the 4 at the bottom, have to do with mathematical discourse, about questioning, eliciting student thinking in different ways, mathematical representations, and supporting productive struggle in order to support students in the teaching and learning of mathematics. Now, you'll also notice that there are 9 equitable teaching practices over on the other side. And these set of practices were introduced to have us to think about really having a lens for equity, really thinking about the equitable opportunities for all students, for each and every learner. And you'll look that it focuses on student funds of knowledge, establishing classroom norms for participation, looking at students as they are capable of doing this and believing that, monitoring how students position each other and how they interact, attending explicitly to race and culture, recognizing multiple forms of discourse and language as it is a resource, and really press for academic success for each and every learner. And then attend to students' mathematical thinking, very similar to the other practices, and then supporting development of sociopolitical dispositions, what we believe matters. So let's think about these 2 frameworks, and let's look at them a little further. So what might be some ways that we might study these mathematical teaching practices? Well, in the last ICRSME, we brought together a group of math teacher educators and researchers to discuss this very thing. And they discussed different aspects of the mathematics teaching practices, but we ended with thinking about what are some areas that we could study that needed further research that we wanted to engage in. And here's a list of some of the things that that group determined. This by no means identifies all the areas to be researched or that have been researched, but these are ones that they were interested in focusing on at that time. For example, examining pre-service and in-service teachers and pre-K through 12 learners' understanding of critical mathematical content. This was very important. A second one was examining pre-service and in-service teachers' instructional practices around different types of questions asked and leading even up to how you get students to ask the kinds of questions they need to be asking as well. Another was analyzing learners, whether it's a pre-K through student or a pre-service teacher, an in-service teacher, looking at their written responses when they're working problems and having them reflect and to unpack their mathematical thinking. The next one has to do with investigating the role of and types of mathematical discourse that support mathematical thinking. They wanted to look at this even further. And again, there's much research out there about that, but they wanted to look more deeply at it. Another one was using a particular format. They were called mini vignettes. And these I've used these in my own research and thinking about these mathematical teaching practices and helping pre-service teachers and in-service teachers to unpack those through looking at sort of many cases of situations in a classroom, maybe around a particular mathematical problem. Another one is to conduct observations. We do this quite often, but to really conduct them in the sense of looking at pre-service and in-service teachers as they're engaging in classroom teaching to really analyze mathematical teaching practices that maybe they want to focus on. And then the last one is we really understand that there are some instruments out there to really examine mathematical teaching practices, but we also have a need for really deepening our understanding about the kinds of tools that are useful in revealing this type of knowledge. So then another thing that we began to think about is, consider approaches. What is it that we need to be doing to examine the roles of funds of knowledge, for example? How can we position students as capable thinkers and doers of mathematics? And how do we study that? How do we know that that is occurring? What's the evidence? How do we investigate the impact of a variety of forms of discourse and different language aspects and the impact? And again, engage in understanding and developing social justice and equity dispositions, and as a lens on how it impacts student identity, agency, and understanding. These are critical for us to learn more about, and how it impacts their understanding and engagement with mathematics. So remember, there were 4. So here's the 4th recommendation about developing deep mathematical understanding. And this is actually a part of the first one that I mentioned, but this goes very strategically, deeply into the kind of mathematics that is taught at early childhood and elementary, middle school, and high school. And you will see things like sense-making, reasoning, high-quality mathematics learning, key kinds of tasks that they need to do, pathways that will actually lead to opportunities for students in the future. So if we consider aspects of this recommendation, what does current research have to say? What do we already know? What other types of research would be beneficial in examining pathways and different ways of thinking about the mathematics so that students are engaged very deeply in mathematical understanding? And again, who are our partners? Who are our stakeholders? So when I think about these 4, they are not separate, and they are not linear, and they are not circular, but instead they are interactive. They relate to each other, and that's why you see all of the different arrows in here. So I wanted us to think about the idea of, when you're thinking about broadening the purposes of learning mathematics, that is directly connected to the structures that are in place and the practices that are used to teach, as well as how they develop deep mathematical understanding. You can pick any one of the 4, and you can look at ideas behind how they are connected to the other recommendations and pieces of those. So it's important for us to think about those connections, the impact, the implications, as we're thinking about researching potential actions we might take in relation to these recommendations. So as we think about that, let's think about, what are the variables involved? What are the different contexts that need to be looked at? What are other considerations? And again, the idea of partnerships. Who do we need to involve in looking at these recommendations and actions that we take? So there are many things that we could study. I did sort of a quick cursory look at some of the things that have been done so far in studying mathematics education, and there are so many. These are just a few examples. Teacher noticing of mathematical thinking very much connects to those recommendations. Examining learning trajectories, looking at different types of intervention, whether it be play, curriculum, technology, and its impact. Functional thinking, and you could expand it to other kinds of mathematical thinking, algebraic thinking, rational number thinking, proportional thinking. So we need to look at that, and there are people that are actually studying that. There are researchers that are looking at the role of language. They're looking at conceptual and procedural understanding and trying to get a better understanding of what those mean and how they inform each other. The impact of teacher attitudes on student thinking along a variety of different areas. Teaching with technology, so important, we have found today. So many more teachers are using technology and trying to find out the best ways to use it so it engages students in deep learning of mathematics. And there's much study out there, but much more to be done about inequities that occur and how we can overcome those. The various knowledges for teaching, the knowledge, the content knowledge, the specialized content knowledge, the knowledge of content and students, and the knowledge of content and teaching. Much research has been done in these areas, but there are more nuances that need to be looked at. What about the impact of parent and families' beliefs, math fluency, task selection? These are all areas that are currently being studied, and many, many more. These are just some examples. But what are others? So again, these 4 recommendations are around these 4 areas. They have a lot of subparts, but it makes us think about, what is our role in thinking about actions to take and ways to determine if they're effective? So in our particular field, how can we take these recommendations and study them, enact them and study them and see if they are helping students learn and engage in mathematics in deeper ways. Some questions to consider is, what critical conversations do I want to begin and why? And how can I engage global partners? So I want us to think about this as individuals and collectively. Who should or could I consider as stakeholders and collaborators in those conversations? How can I engage those stakeholders to build partnerships? What kind of research methodologies would be beneficial? Some of the research I mentioned earlier, those areas are studied in many, many different ways. What are the most effective ways? And the last one, what are effective ways of sharing the results with the broader mathematics education community so that we're all learning? So there are various actions in catalyzing change that are noted that we could think about, many actions that we could take, and we'll talk about that in a moment. But I'd like for you to think for just a minute about potential actions that we as teacher educators and researchers could take. Is building those strong partnerships for equitable mathematics instruction. We could take actions toward that. What about collaborating with families, policymakers, school, districts, states, provinces, cross-country, global educators to challenge and dismantle structures and practices that really impede access to and success in mathematics and develop quality mathematics pathways for students? We can do this together. Another is we could collaborate with both in-service and pre-service teachers to support research-informed and equitable instructional practices. We need to do this together. Design research in collaboration with local and global partners. Support teachers in their own inquiry, action research, lesson study, reflective practices that they may do. How can we collaborate with teachers? And consider research that would inform policies and practices that are both inclusive and transformative. So I challenge us, what are we going to do? Who will we engage in these conversations? What areas will we study? How can we build global partnerships? So I ask for you to think about that next step or that next action for you related to envisioning research in mathematics education. So I'd like for you to share your ideas, if you will. You can go to this menti.com and it's got / and then some letters and numbers afterwards, or you can use the QR code. But it's a document that you can go in and add your own idea about an action or step that you might take. It's anonymous, so we won't know who entered it. You can enter more than one. So you may have multiple things that you are working on that you think will contribute to this, or things that you're thinking about doing. So let's share some of those things so we can think together as a global community about mathematics education. So as I close, I want to share one of my favorite quotes. This is from Catalyzing Change in Middle School Mathematics. And it says, enacting long-term, impactful change will require time, collaboration, communication, and hard work across many different stakeholder groups. But in the end, it will be worth it. So I thank you, and I hope together we can envision research in mathematics education from a global perspective. With the current COVID-19 global challenges and continued injustices, let's work together as a global community of researchers and educators to intentionally and strategically examine the issues and the impact on mathematics teaching and learning, and take actions to address and study the impact to contribute to mathematics education. Please feel free to reach out and email. Would love to hear from you. And also think about attending the NCTM conference. The next one is virtual and it will be in April. Hope to see you there. Thank you.